The Bernhard Chili Factory creates batches of chili that are 280 ounces each. Each batch of chili is then put into a number of containers, each of which is either a 10-ounce container or a 16-ounce container. If exactly 22 containers were filled with no leftovers, how many 10-ounce containers were filled? And we're going to solve a word problem using multiple variables. Now, when I think of multiple variables, I would think that we would be using, say, x and y, and it might look something like this. We might say that, x number of 10-ounce containers plus y number, of 16-ounce containers equals, 22. But I'm going to quickly see that that isn't really going to get me anywhere unless I want to change, like one of them into, y equals 22 minus x, which is indeed what I've done down in the chart below. And I'll show you why, rather than using x and y, I went straight to that. Because I said to myself, well, if I have 10-ounce containers and then some 16-ounce containers, but altogether they have to make 22 containers, then if I have x number of 10-ounce containers, 22 minus x is going to tell me the number of 16-ounce containers. So at this point, I've built a little chart that says that I have 10-ounce containers, and if I multiply that by x, I get this 10x over on the side here for the total number of ounces for the 10-ounce containers. So no matter how many 10-ounce containers I have, I'm going to multiply that x by 10. For my 16-ounce containers, I'm now calling those 22 minus x, because I don't know how many there are, but I know that together the 10 and the 16 have to make 22. So then my variable for the 16-ounce containers is 22 minus x instead of y. And it looks a little scary, but it still is going to work when we get to our equation. So now I have some 10-ounce containers and some 16-ounce containers. And I'm going to add these two together to make my total number of ounces. Because remember, 10 times the number of containers will tell me how many ounces are in all of those containers, and 16 times the other number of containers will tell me how many ounces are in those. So together, that created this equation down here, kind of a part total, okay? 10 ounces times the number of 10-ounce containers plus 16 ounces times the number of 16-ounce containers tells me how many ounces I'm going to have all together. Now, most students, once they got to this point, could probably finish the problem. I believe most people have the most trouble building the equation. But we're going to finish it out anyway, just in case there's some trouble after this. So if we start by distributing on the left-hand side, we're going to leave our 10x alone for now. But 16 times 22 is going to give us 352. And that's my first distribution. Then I'm going to distribute again. And I'm going to say minus, because there's a minus sign in between there, 16x. And then it's still going to equal 280 ounces. Now I'm going to combine like terms. So I'm going to get negative 6x, because negative 16 and positive 10 make negative 6. And then I'm going to take the 352 away from both sides. Now the absolute value difference is 72, and it's going to be negative 72 because 352 is bigger than 280. Then when I divide, I'm going to be back into positive numbers, which is good since I'm finding a number of containers. Negative wouldn't make any sense. And now I see that I have 12 10-ounce containers. Now we should know that if I have 12 10-ounce containers up here, that means I have 10 16-ounce containers. And I could double check my work by going back and multiplying 12 times 10 and 10 times 16, adding those together, and I should get my 280 again. So that is how we would solve this, and since we used the 10-ounce container as our variable, we went straight to the answer. If we accidentally had used the other one as the variable, the 16-ounce, we would just go back, and just like I found out there were 10 16-ounce containers, I would have subtracted and found out there were 12 if it had been the other way around. So you can even make kind of minor, quote, errors in your setup, as long as in the end you go back and catch that you found the opposite of what you meant to find. It will still work in the end. Mathematically, we were doing the same procedure. All right, our second is number 2, and it's called an engineering lab problem here. And you work in this engineering lab, and you're supposed to make 10 liters of a 15-ounce acid solution for an etch test. But your chemical supplier only stocks 10% and 30% solutions, and you need a 15. Now, because 15 is between 10 and 30, we can mix them and get this. Now, if they only carried 10% solution and something else, you wouldn't be able to do this quite so easily. But because 15 is between 10 and 30, we can do a mixture. So rather than pay the supplier, we're going to mix our own, because the supplier could make it for a special order, it appears to be. So we're going to make a little chart to keep track of our information. And we have a 10% solution, so I'm going to write 10% as a decimal, and I'm going to put it in my percent column. And then I have a 30% solution, but I want to end up down here with a 15% solution. So that's what I'm trying, my goal. So I have to say that I'm working, or I want a total of 10 liters. Okay, that's my goal, is to get to 10. And it's 10 of a 15%, so this is going to be 10 times my 15% solution. And here, I don't know how much I'm going to have of the other. And it doesn't matter which one's the variable, because it just asks me how many, oh no, it does matter if I want to go straight to the answer. How many liters of a 10% solution should I use? So that's my question, is how many of these. And if I'm going to use, I want to end up with 10 altogether, I have to have x and then 10 minus x, because I've used up x out of the 10, the 30 is the other part. And I think that's the little piece that people have trouble with, is that 10 minus x. So then what we're going to do again is we're going to multiply across, and we're going to get sum of a 10% and sum of a 30%, and the sum is the difference between the total and what we've already used. And then we're going to go part plus part equals total. So we're going to go part 10% plus part 30% is going to be equal to a total of 15%, 10 liters of a 15% solution. And even the word like 10 liters of should tell us 10 times, okay? So I have to distribute first, just like the chili problem. My distribution has to happen first, so I have 10%, doesn't change. But my 30 times 10 is going to move that decimal point over one place, and I'm going to get 3 minus 0.30x equals 10, again, just moving my decimal point one place. Now I'm going to combine like terms. I am going to go negative again, and that kind of makes you nervous because you're thinking, how can you have negative? But you find out pretty quickly that the negatives kind of cancel each other out in the end. So if I take 3 away from the other side, I get negative 1.5. Now when I divide two negatives, I'm going to end up with a positive again, and I'm going to end up with positive, what am I going to get here? I think 7.5. Okay, and if you need to go off and do that on the side or on a calculator, that's okay. But it is 7.5. But then I have to ask myself, what was I asked? I was asked to decide how many liters of a 10% solution. I have 7.5, so those must be liters, okay, which I'm not going to be able to probably fit on here. I could just abbreviate it L, but it might look like a number unless you make it kind of an italic L. but 7.5 liters. And let's go see if that's reasonable. Well, first of all, I was trying to make 10 total, so 7.5 is reasonable in that it's less than 10. And that means I'm going to have mostly 10% and some 30%. And that's going to make it go up, right? And I want it to go from 10 to 15. So it all seems kind of reasonable. If I want to test it, I would have to put 7.5 back in for x, calculate it out, and see if I get a true statement. Oops. All right. And on number 3, it costs $9,300 for me to buy a juice bar franchise. But after buying the franchise, it's going to cost me $2 for every glass of juice I make. And I'm going to sell my juice for $5. So I want to know how long before I break even. Well, first of all, you have to understand what break even means. Break even means that I want to get essentially back to zero. In other words, I am negative 9,300 right now in terms of money. I owe that much money, or I have invested that much money from somewhere, and I break even when I get back to zero. So what we're going to first figure out, I do this in a little bit of a two-step problem, because my total price for every glass of juice that I sell is going to be $5. But I have to take out that they cost me $2, so every glass of juice I sell, I'm going to make $3. That's very important because it's going to take me 3 times something to get my $9,300. That's what I have to do. Every time I sell a glass of juice, so this is the number, the question mark's my number of juices. So it's pretty quick, you can see that this becomes 9,300 divided by 3. And then I can see that there are 3 3s in the 9, 1 in the 3, and none here. So I think I'm going to have to sell 3,100 glasses of juice before I break even. Hopefully I sell them rather quickly and I can cover my expenses. But that's why a lot of businesses go under, because maybe I can't sell that many glasses before I, have other expenses. Because this problem is only talking about a profit on a glass of juice. It's not talking about rent and utilities and waitresses to serve my juice and equipment, unless, those were all included in that 9,300. So it's going to take me quite a while to pay off my little investment here, I would think, at $3 a glass. All right, our last problem, number 4, says that sugar can be bought in 1-pound containers or 5-pound containers. So that's a weight. So I made a little chart here and I put 1-pound containers and 5-pound containers. And a grocery store was going to sell 63 pounds of sugar in 23 containers. So again, this is sort of very similar to one of the other problems, like the chili problem. We're filling up 5 and 1-pound containers with 63 pounds of sugar until we get basically a part plus a part and a total. And if we do part total here, we know that, that was an equal sign, sorry. Oh, well, let me change it. Interesting. Sorry about that. Little distractor there. There we go. Part total means total pounds. So the parts have to be weights, okay? So if part 1 weighs 1 pound and part 2 weighs 5 pounds, but it's how many 1 pounds and how many 5 pounds. And we find that out by multiplying 1 times the number of 5-pound containers. And then the other one would be a y, except for the fact that we knew there were 23, so we could make it in relationship to the 23. If some of them are 1 pound, then the rest of them are minus the 1 pound. So the total is 23 minus the 1-pounders tells me how many 5-pounders. So now I have 1x. I have to distribute 5 times 23. So 5 times 3 is 15, and 11, I think that's right. Minus 5x equals 63. And then x minus 5x is negative 4x. Again, I get a little nervous when we go negative with these because I think, oh, I can't have negative. But you have to remember that the negative might kind of wash out in the end. And yes, I am stalling while I'm subtracting 63 from 115, and I'm getting 52. And then hopefully that divides evenly by 4. There's 1, 4, it looks like 13. So I'm thinking there are 13 1-pounders. Now you can see if I go back up here, if there are 13 1-pounders, then there are 10, because 10 and 13 is 23, 5-pounders. And then you kind of go say, is that reasonable? Well, 10-pounders will make up 13 and 10. You'd have to go 13 plus 5 times 10. Yeah, 50 and 63. That makes perfect sense. Boy, I shouldn't do these late at night. Because 1 times x means there's 113 and 5 tens. So 113 and 5 tens is indeed 63. So that one's fairly easy to even check. And I think that was all of them, and I hope you found this helpful.